Welcome to the tutorial room. Select a topic you would like to visit. Chapter 8, Section 8.5, Multiplying Algebraic Expressions. In this section, we'll teach you how to multiply algebraic expressions using the commutative, associative, and distributive properties of multiplication to multiply each term in the first factor by each term in the second factor. You'll also learn about the FOIL method, first, outer, inner, last, for multiplying expressions with two terms. To multiply algebraic expressions, we use the commutative, associative, and distributive properties of multiplication to multiply each term in the first factor by each term in the second factor. You've already had some practice multiplying single terms on the last several screens, but let's re-examine these steps. Example 8.5.1. Find the product of 4x squared times 3x cubed. To find the product of two terms, we can restate each expression as the product of the coefficient times the variable. Then rearrange the factors using the commutative property of multiplication. Next, we group the coefficients together and the variables together. Then find the product of the coefficients and the product of the variables. Since the variables have the same base, to find their product we can simply add the exponents using the product rule of exponents. To multiply a single term by an expression with two terms, we use the distributive property. Example 8.5.2. One term times two terms. Find the product of 4x squared times 3x cubed plus 2x squared. To multiply a single term by two terms, we use the distributive property to multiply the single term by each one of the two terms. Since our expression now consists of the sum of the product of two single terms, we multiply using the procedure for single terms that we used in example 8.5.1. That is, we multiply the coefficients and multiply the variables. Then write the sum of the products. We can expand the distributive property to multiply a single term by multiple terms. Example 8.5.3. One term times three terms. Find the product of 4x squared times 3x cubed plus 2x squared plus 6x. To multiply a single term by any number of terms, we expand the distributive property to multiply the single term by each term in the second expression. 4 times 3 equals 12. X squared times x cubed equals x to the fifth. 4 times 2 equals 8. X squared times x squared equals x to the fourth. 4 times 6 equals 24. X squared times x equals x cubed. Then write the sum of the products. Example 8.5.4. One term times four terms. Find the product of 4x squared times 3x cubed plus 2x squared plus 6x plus 7. To multiply a single term by any number of terms, we expand the distributive property to multiply the single term by each term in the second expression. 4x squared times the first term. 4x squared times the second term. 4x squared times the third term. 4x squared times the fourth term. Then write the sum of the products. If the expressions contain minus signs, think of subtraction as adding the opposite and rewrite the expression with plus signs and negative coefficients. Example 8.5.5. Find the product of 4x squared times 3x cubed minus 2x squared minus 6x. 4x squared times 3x cubed minus 2x squared minus 6x equals 4x squared times 3x cubed plus negative 2x squared plus negative 6x. To subtract, add the opposite. equals 4 times 3 times x raised to the power 2 plus 3 plus 4 times negative 2 times x raised to the power 2 plus 2 plus 4 times negative 6 times x raised to the power 2 plus 1. Multiply coefficients and variables. Keep track of negative signs. Equals 12x to the fifth plus negative 8 times x to the fourth plus negative 24 times x cubed. Write the sum of the products. Equals 12x to the fifth minus 8x to the fourth minus 24x cubed. Clear parentheses. Keep the signs the same since they're preceded by a positive sign. When we multiply an expression with two terms by another expression with two terms, we multiply each term in the first expression by each term in the second expression, using the steps known as the FOIL method. FOIL stands for first, outer, inner, last. The FOIL method helps us make sure that we have multiplied each term in the first expression by each term in the second expression, by helping us remember a specified sequence for multiplying the terms. Find the sum of the products in this order. 1. Multiply the first two terms in the expressions. 2. Multiply the outer terms in the expressions. Multiply the first term in the first expression times the second term in the second expression. 3. Multiply the inner terms in the expressions. Multiply the second term in the first expression times the first term in the second expression. 4. Multiply the last two terms in the expressions. For example, to multiply a plus b times c plus d, we find the sum of the product of the terms in this order. FOIL equals f plus o plus I plus l. A plus b times c plus d equals a times c plus a times d plus b times c plus b times d. 1. Multiply the first two terms in the expressions, a times c. 2. Multiply the outer terms in the expressions, a times d. Multiply the first term in the first expression times the second term in the second expression. 3. Multiply the inner terms of the expressions, b times c. Multiply the second term in the first expression times the first term in the second expression. 4. Multiply the last two terms in the expressions, b times d. Example 8.5.6. Two terms times two terms. Find the product of 4x squared plus 5x times 3x cubed plus 2x squared. To use the FOIL method to multiply expressions with two terms, first find the product of the first term in each expression. Next, find the product of the outer terms in the expression. Then, find the product of the inner terms in the expression. Finally, find the product of the last term in each expression. Then, multiply the coefficients and the variables and write the sum of the products. Combine the like terms. And write the final answer. To summarize, here's the general procedure for multiplying algebraic expressions. Now, try some practices. Yes, you are right. Good job, you're right. Good job, you're right.